Hi there, Miss Ferber here. This lesson is titled Problem Solving with the Normal Distribution. We have one learning objective for this lesson, and that is to be able to solve applied problems that involve the normal distribution. Let's get started. Example: the weights of toddler boys are normally distributed with a mean of 28 pounds and a standard deviation of 2 pounds. Find the percentage of toddler boys who weigh as follows. Part A, less than 32 pounds. To solve problems that involve the normal distribution, we typically begin by drawing the normal distribution. So let's draw our bell curve, and I'll mark to the side that the mean is given in the statement of the problem as 28 pounds and that the standard deviation is 2. I will write the standard or z-scores along the bottom. The z-score that corresponds to the mean is 0. For this problem, it's 28 pounds. Let's go to the right. Standard score of 1, that would correspond to an actual weight of 30. We're trying to get to 32 here. And a standard score of 2, that would correspond to an actual weight of 32 pounds. Now we want to find the percentage of boys who weigh less than 32 pounds. So let's shade the region that would correspond to the left of the standard score of 2 under the bell curve. Now we'll use the empirical rules. To the left of 0 is 50% of the total area. Now let's look at the right. Between -2 and +2, empirical rule tells us that that's about 95%. However, we've already taken care of the area on the left-hand side, so you only need half of the 95. Then you'll have 50% plus half of 95%. That would be 47.5%. So we can conclude that about 97.5% of all toddler boys weigh less than 32 pounds. Let's go to part B, more than 32 pounds. Again, we're still working with the normal curve. So let's draw our bell-shaped curve. And in part A, we learned that 32 pounds corresponds to a standard score of 2, and this time we want the area to the right of the standard score of 2. Let's use geometry, knowing that the entire area under the curve is 100%. And in part A, we learned that boys who weigh less than 32% comprised of 97.5% of the area. So those who weigh more than 32% would be the 100% minus the 97.5%, and that gives us 2.5%. Continuing, let's find the percentage of toddler boys who weigh between 24 pounds and 30 pounds. Again, we'll pursue by drawing a bell curve, and I'll mark the 0 as the standard score mean. We know that the weight that corresponds to that is 28. Now let's find the corresponding z-scores for 24 pounds and for 30 pounds. We want the z-score that corresponds to 24 pounds. The formula we have says that you take the data item, which is 24, minus the mean given in the statement of the problem as 28, and divide it by the standard deviation, which is 2. That'll be equal to, in the numerator, -4 divided by 2 in the denominator. We get a standard score of -2. Let's draw that. I'll mark -2 along the horizontal and put 24 on the bell curve. And now I need the z-score that corresponds to a weight of 30. Again, that's going to be the data score, 30, minus the mean, 28, divided by the standard deviation of 2. The numerator, 30 minus 28, is 2. Divided by 2 in the denominator, we get a standard score of 1. Let's sketch that onto our graph. I'll draw 1 along the horizontal and 30 along the bell curve, and I'll shade the area we need to compute. That area is between the standard score of -2 and standard score of 1. There are several different ways in which you can do this. I'm going to use the empirical rule. The empirical rule tells us that between -2 and +2, you've got 95% of the total area, but we only want half of that. We want that to the left of the 0, and the empirical rule tells us that between -1 and +1, that's 68% of the total area. However, we only want half of that also because we only want it between 0 and 1. That's to the right of the mean. Let's compute this. Half of 95% is 47.5%, and we'll add that to half of 68%, that's 34%, and adding those two percentages together, we get 81.5%. What we have found is that about 81.5% of all toddler boys weigh between 24 pounds and 30 pounds. Part D, less than 22 pounds. We still have the same criteria, so let's draw the bell curve. I'll mark the 0. It's always nice for me to know where the mean is. And I want the z-score that corresponds to 22 pounds. So the z-score that corresponds to 22 pounds would be the data item of 22 minus the mean, given as 28, divided by the standard deviation of 2. The arithmetic takes us to -6 in the numerator, divided by 2. We have a standard score of -3. Let's mark -3 along the horizontal to the left of the 0. And above that, I'll write 22 to indicate the pounds. What we want is the area to the left of -3. There are a couple of ways in which you can solve this. What I'm going to do is use the empirical rule. The empirical rule tells us that between standard scores of -3 and 3, we have 99.7% of the total area. So if I wanted both ends, we could compute 100% minus 99.7%, which is 0.3%. However, we only want the left half of it, and since it's symmetric, our next step would be to take the 0.3% and divide that by 2. Doing so, you'll get 0.15%. That is 0.15% of all toddler boys weigh less than 22 pounds. Example, use the percentiles for weights of adult men over 40 to find the percentage of men who weigh, Part A, less than 227 pounds. The table we are provided has 2 columns. The first is titled weight, and the next column is percentile. For a weight of 227 pounds, the percentile is listed as the 3rd quartile. Let's remember the 3rd quartile corresponds to the 75th percentile. Let's draw a normal curve to see the area. We'll mark where the 75th percentile would be and indicate that that's 75% of the total area under the curve, the normal curve, that corresponds to 227 pounds. So, what percentage of men weigh less than 227 pounds? 75%. Part B, more than 235 pounds. Let's reference back to the table. For the weight of 235 pounds, the percentile is listed as 86. Now let's be careful. 86th percentile tells us that 86% of men weigh less than 235 pounds. This problem asks us to find the area to the right of 235 pounds. So the area under the entire normal curve is 100%. We're going to subtract the 86%, and the difference gives us 14%. So we'll conclude about 14% of all adult men over the age of 40 weigh more than 235 pounds. Part C, between 227 pounds and 235 pounds. Looking at the chart provided, we see that men who weigh 227 pounds, that's within the third quartile, and for 235 pounds, it's in the 86th percentile. Let's sketch this under a normal curve. And we've got two percentiles to consider, but I'm going to begin with the weights. 227, and to the right of 227 be 235 pounds. The table provided indicates that about 75% of men in this category weigh less than 227 pounds, and the table also indicates that about 86% of all men in this category weigh less than 235 pounds. What we are looking for is the area between 227 pounds and 235 pounds. That would be 86%, which corresponds to the 235 pounds, and 75%, which corresponds to the 227 pounds, the difference of which is 11%. So about 11% of adult men over the age of 40 weigh somewhere between 227 and 235 pounds. Now we'll do some examples where we will use our calculator. Be sure to write down the calculator keystrokes as you learn them. Example: the weights of 12-month-old baby boys are normally distributed with a mean of 22.5 pounds and a standard deviation of 2.2 pounds. Find the percentage of 12-month-old baby boys who weigh as follows. Part A, between 19.2 pounds and 23.1 pounds. As with the previous problems, let's begin by drawing our normal curve, horizontal line in a bell-shaped curve. The problem tells us that we have a mean of 22.5 pounds, so that would correspond with a z-score of 0. We'll write the 0 right smack in the middle at the bottom and 22.5 on the top. And we have a standard deviation of 2.2 pounds. Now let's find matching z-scores. I want a z-score for the weight of 19.2 pounds, and that would be the data item 19.2 minus the mean, which is 22.5, divided by the standard deviation 2.2. The numerator, 19.2 minus 22.5, that's negative 3.3, and we divide that by 2.2, so that's equal to negative 1.5. Let's mark that z-score on our bell curve. To the left of 0, I'll mark negative 1.5, and right above it, I'll write 19.2. Now let's find the z-score for the weight that corresponds to 23.1 pounds. Using our formula, it'll be the data item, which is 23.1, minus the mean, given in the problem as 22.5, and we'll divide that by the standard deviation of 2.2. For the numerator, 23.1 minus 22.5, that's a positive 0.6, and we'll divide that by 2.2, and that's close to 0.27. Let's draw that on our normal curve as well. I will mark the 0.27 to the almost immediate right of the 0. Draw a line up to the edge of the bell curve and write 23.1. And the area we seek is between the weights of 19.2 and 23.1, which is also between the z-scores of negative 1.5 and 0.27. Let's use our TI-84 to compute the area. This is the screen of a TI-84 Plus CE. This calculator has a feature that lets us compute the area under a normal curve. To do so, we want to go to the distribution, so hit second, and then where it says VARS, click on it. Right above it is the DISTR function. The first two that pop up are normal PDF as in pickle DF and normal CDF as in cookie. For us, we always pick the normal CDF, so click 2. And then you get a screen display that has lower, upper, mu, sigma, and paste. For our problem, for the lower, we put in negative 1.5. Press enter. For the upper, we put in 0.27. Press enter. For the mu, press enter for the standard deviation. And when you paste, the screen displays normal CDF, open parentheses, negative 1.5, comma 0.27, comma 0, comma 1 close parentheses. Press enter to get your output of 0.5396125.859. And transferring the score from our calculator, we get that the normal CDF is approximately 0.5396125.859. And we can conclude the percentage of 12-month-old baby boys in this weight range is about 53.96%. Part B, between 18.1 pounds and 21.5 pounds. We'll proceed as before by first drawing a bell curve. So draw a horizontal line and a bell shape. I'll mark. The mean is 0, and we learned in the previous page that the mean weight was 22.5, and the standard deviation is 2.2 pounds. We need to find z-scores that correspond to 18.1. So the formula tells us you take the data item, which is 18.1, and subtract the mean, which is 22.5, and divide it by the standard deviation of 2.2. The numerator, 18.1 minus 22.5, that's negative 4.4. We'll divide that by the standard deviation of 2.2, and we get negative 2. Let's mark that on our graph. I'll go to the left of 0 and write negative 2 for the z-score, And right above it, I'll write 18.1. Now let's find the z-score that matches the weight of 21.5 pounds. Formula tells us you take the data value, which is the 21.5, minus the mean, which is 22.5, divide that by the standard deviation of 2.2. The numerator becomes -1, and then we still divide that by 2.2, and that gets us roughly -0.45. Let's mark that on our graph as well. It'll still be to the left of the 0, but pretty close. So I'll mark -0.45, and above that on the bell curve, I will mark the weight of 21.5. The area under the bell curve between -2 and -0.45 gives us the percentage of baby boys in this age group that weigh between 18.1 pounds and 21.5 pounds. Let's use our calculator to compute this area. We're using the TI-84 plus CE again. We want to get to the distribution feature, so from your keyboard select second, and then pick the VARS, which takes us to the distributions. Several of them show up. What we want is number 2, normal CDF, so select the CDF. We computed the lower and upper values. The lower value we computed is -2, enter, and then the upper value we selected is -0.45. For both the mu and the standard deviation, 0 and 1 are appropriate since we are using standardized scores, so we enter, click on paste, and enter again. Here the screen displays normal CDF, open parentheses, -2, comma, -0.45, comma, 0, comma, 1. Press enter, and the output that you get is 0.3036051,788. And transferring the value from the calculator screen, we have that the normal CDF is approximately 0.3036051788, and we can round out to say that the percentage of 12-month-old baby boys in this weight range is about 30.4%. Part C, more than 25 pounds. Again, we begin by drawing sketch of a bell curve that's a horizontal line with a bell curve. I always draw the mean, that's 0, and I'll mark the 22.5 pounds. Standard deviation is given as 2.2. We want more than 25 pounds. Even so, we still need to compute the z-score that corresponds to 25. The formula tells us that's the data item, so that's 25 minus the mean, which would be 22.5, and divide that by the standard deviation, which is 2.2. In the numerator, 25 minus 22.5, that's 2.5. Still divide by 2.2, and that gets us to 1.14. Let's draw that on our graph. 1.14 would be to the right of the 0. Let's go up and draw a dashed vertical line, and I'll write 25. The area that we are looking for is to the right of the 25. We'll use our calculator to solve for this area, which gives us the percentage. Using the TI-84, let's go to the distribution tool. So we'll hit second, VARS, and we want the normal CDF, select 2. Now this one, the lower starting point, we computed as 1.14 and press enter. The upper goes on indefinitely. If -3 and +3 gets you close to 100%, then we could just pick a real large number for the upper end, and I'll put in 10,000. Press enter. Still use 0 for the mean, 1 for the standard deviation. Select paste. Your screen should show normal CDF, open parentheses, 1.14, comma, 10,000, comma, 0, comma, 1, close parentheses. Press enter again. The output is 0.12714322013. Transfer in the screen from our calculator. We have that the normal CDF is approximately 0.12714322013. That is, the percentage of 12-month-old baby boys in this weight range is about 12.7%. Part D, less than 18 pounds. Again, let's draw the normal curve. That's a horizontal line with a bell-shaped curve above it. Always mark the mean. Standard score is 0. The mean is given to us in the problem as 22.5. The standard deviation is also given, and it's given as 2.2. This problem asks us to find the weight that's less than 18 pounds. We need to find the z-score that corresponds to 18. The formula is the data item, in this case is 18, minus the mean, that's 22.5, divided by the standard deviation, which is 2.2. 18 minus 22.5, that's negative 4.5. Let's divide that by 2.2. And that quotient is negative 2.05. Let's draw that onto our graph. So negative 2.05 will definitely be to the left of 0. Mark that. Draw a vertical line up to touching the curve, and I'll write 18 where it matches. Less than means to the left of. Now, using our calculator, compute this value. Let's get one more practice in using the normal CDF feature. Remember, we hit second, then the VARS. We want the second one, which is the normal CDF, so click 2. We want to go from as far left as you can, so we'll leave the lower at -1E99, that's the default setting. And then for the upper, we solved for -2.05. The scores are standardized, so we're good with the mean being 0 and the standard deviation being 1. Click paste and enter. You should see something like normal CDF, open parentheses, -1E99, comma, -2.05, comma, 0, comma, 1, close parentheses, and then click enter. The output is 0.0201821,477. Transferring the result from our calculator, we get that the normal CDF, as computed in your calculator, is approximately 0.0204049. And we conclude the percentage of 12-month-old baby boys in this weight range is about 2%.